So this is the chart that I hope you have something like this in your notes somewhere about various criteria for judging voting systems. And so far we have talked about these 4 different voting systems. And you know, since the test is coming up, I hope that you remember what everything you see here means. So going down the left side are 4 different voting systems. The plurality system is when you just count up the first position rankings and see who got the most. That's the plurality system. Then the RCV is the ranked choice. That's the one where you do rounds and eliminations. The next one is the Condorcet method, which is the one where you look at all of the pairwise matchups of the candidates and see who would win in any pairwise competition. And then the Borda is the one where you give points per ranking and add up all the points. And then these criteria are 3 different ways of judging how good a system is. So the first one here is the majority criterion. The first 3 satisfy the majority, the Borda does not. What that means, remember what this criterion means? It means that if a majority of the voters rank somebody in the first position, then that person should win the election. And that is actually true of plurality, ranked choice, and Condorcet method. It's not true of the Borda. That's because it is actually possible for someone who comes in second place a lot to win the Borda if they get, because the second place person can get a lot of points, and it is possible they can end up winning even against someone who is ranked first by a majority. Okay, the next was the unanimity property. I hope you remember the unanimity means that if all voters ranked X above Y on their ballots, then Y should not be the winner of the election. And then the Condorcet winner criterion, that means if there is somebody who would have been the winner in the Condorcet's method, that is, if there is somebody who wins all of their pairwise matchups, then they should also be the winner of the election. And that is not satisfied by most of these, as we discussed last time. All right. So several of your homework questions for the homework that's due tomorrow are about various bits and pieces of this chart here. Like, explain to me why the ranked choice satisfies the majority criterion, something like that. That would be a decent homework question. That would also be a decent test question. Like, you should expect, you know, I said there will be a question on the test about the unanimity property. You should expect me to ask you something like, explain to me why the ranked choice satisfies the unanimity. And you have to explain to me why the ranked choice satisfies the unanimity. I hope that you feel like that is doable. You may want to look over, you know, if you do the homework tomorrow and everything seems to make sense, then you should feel good about the test. All right. Any thoughts about this? Yeah.
In general, I had a question for the homework because in the question 1A about the Condorcet method, often there was no winner. It was like 4-4. And I'm sure. Do I then look who has the most wins and like equal?
No, in that case you just say there is no winner. That's it.
Yeah, but like for example, you could see that, Woe, I don't know, like the saloon, Woe had 2 wins and 1 equal, and the other had either 1 or 0 wins. Is it then? Right. Is Wu then the winner or is
no?
Nothing?
You just say nobody is the winner. Yeah, I mean, there is some way you could say maybe this person won more of their matches than somebody else, but nobody counts as the Condorcet winner. Yep. Yeah, so that actually is a little misleading. Like, according to this chart, it seems like Condorcet's method is definitely the best one. And according to these 3 measurements, it is good according to those 3 measurements. But the major problem with the Condorcet's method, and the reason why we don't use it in the real world, is because there's not always a winner when you do Condorcet's method. So these checks are a little bit of a disappointment. I mean, in theory, the Condorcet method would be an awesome system, but it often doesn't choose a winner, and that makes it really almost entirely impractical in the real world. All right, I got 2 more things that I want to talk about today. 2 more major topics. That is 2 new columns on the chart here. And actually, we're going to talk about a new row also. But what I want to start off with is another criterion. A new criterion. This is another way of judging if one of these systems is good or not. And this is called The monotonicity criterion. This is the one that I accidentally put on the homework assignment for tomorrow. I didn't mean to. I'll look for an email about that. After we do it today, you can do this question, but I didn't intend to put it on there. I meant to wait till next week. The monotonicity criterion. So I'm actually going to, would you mind if I put this right on there? The monotonicity, all right? This is a big fancy word, monotonicity. That's the noun form of the adjective monotone. And when we say something is monotone, it means like it sort of sounds the same all the time. That's like the ordinary English word monotone. That's what that means. In a mathematical context, the word monotone, this actually is a word that's used in mathematics in other contexts. Monotone means something like always the same direction. This is generally what the word monotone means in mathematical verbiage. In ordinary language, monotone just means like it sounds the same all the time, but in mathematics, usually it means always moving in the same direction, something like that. Something which is monotone, it's like always going up rather than up and down sometimes. Always up or always down or something like that. All right? And you'll see what the word has to do with the criterion once in a moment, once we explain some things. So the monotonicity criterion is about people changing their minds. This is a little strange just because in real life, when you vote, you're not allowed to change your mind after you vote. And so there is no such thing in real life as people changing their minds in an election. But this is about if you imagine someone was going to change their mind, then you can imagine what would the effect on the election be. So this is about people changing their minds. Like, for example, if I was gonna put A on top, but then I swap it with B, right? You just imagine that somebody, I was thinking about voting for Trump, but then I decided instead I'm going to vote for Biden. All right, this is the kind of changing of the mind that I'm thinking of. Not about someone actually voted and then later on changes their vote. That's not allowed. But just in your mind thinking about what happens if I change your mind. Now, if I was going to put A on top and then I decide to swap it with B, put B on top instead, what should the result of that be? Well, if I'm just one man voting, probably that doesn't make a difference in the overall scheme of things. But if anything, this should help the B, right? If I was going to put A on top, and then I decided to change my mind and put the B on top, this will give a little boost to B, right? It'll give them, one more vote than they used to have or something like that. Okay, so I'm going to say, if I was going to put A on top, but then I swap it with B, I will just say parenthetically, this should help B, right? That's the idea. Then this is the concept behind the monotonicity criterion. And this is what the sort of same direction means. It means if I move B up to the top of my list, then this should help B out in the end. They should go sort of in the same direction. I help out B, B gets helped out. Rather than the opposite direction would be like if somehow I move B to the top of my rankings, but this caused B to lose the election. That should not happen, all right? This is what the monotonicity criterion is all about. Here's a specific example. This is a made-up example. Let's say we have this example. Let's say 5 people put A, B, C, 4 people put C, B, A, 3 people put B, C, A, 1 person puts B, A, C. All right, and let's imagine that we're doing the Borda. All right. Remember, the Borda is the one where you add up the points. Let's see, can we calculate the answer using the Borda? This would be a simple test question about the Borda. I just show you an example and say, tell me who the winner is using the Borda. So I hope you remember how this goes. I'll put the points like this, right? Last place gets 0 points, then 1 point, then 2 points. And we have to add and multiply to count up the scores. So how many points does A get? A has 5 voters, giving them 2. So this says 5 times 2. In the next column, it's a 0. Really 4 times 0, but that doesn't matter. In the next column, it's 3 times 0. And in the last column, it's 1 times 1. That's because one person here gives 1 point. And this, add them all up. Remember, you have to multiply first and then add. So this is going to be 10 and a 0 and a 0 and a 1. That's 11 points for A. All right. On the test or something, you don't have to write out all the steps if you don't want to. I would expect you to write some. I suppose you could try to do all this in your head. I don't know. Some people like to flex by doing everything in your head. I don't recommend it. You won't impress me personally, but you can impress your friends, I guess, by doing things in your head. What about B? Okay, B is going to be 5 times 1 plus 4 times 1 plus 3 times 2 plus 1 times 2. I hope everyone sees how I do this. I multiply the number at the top by the point value in each position. This is 5 and 4 and 6 and 2, which is 9, 15, 17. All right? And when I do C, same idea. This time it's going to be 5 times 0 plus 4 times 2 plus 3 times 1 plus 1 times 0. This is 0, 8, 3, 0 is also 11. B wins. All right? I hope everybody's clear on that, and I hope I didn't screw it up. Any questions about just doing the borda, okay? Now, this is not what I really wanted to talk about. I was trying to talk about the monotonicity criterion. Let's ask ourselves, if one of these people changes their minds, let's ask about, how about this CBA folks, all right? What if these CBAs, if the CBAs change their mind to, let's say, BCA, all right? What will the effect be on the results? Now, check it out. B was the original winner, right? And what I'm describing here is a bunch of people changing their mind. Maybe I'll just, to indicate, B was the winner. They just raised B up. Can anybody predict? I mean, you don't have to rerun the numbers, but can you predict who's going to be the winner after you make this change? Yeah?
B, because it already won. And
Yeah. She says B will still be the winner because B was the original winner. And all we did when we make the change was we raised B up somewhere, right? So that means B will get even more points. I guess actually A will get the same number of points. And C will get a little bit less because C used to be on top from these people, and now they're going down to the second position. All right, so if the CBAs change to BCAs, what's the effect of that? Then B gets even more points, so B still wins. All right, if you feel like this is an obvious fact, then you are on the right track. I hope that what I'm saying seems obvious. If somebody was going to win before and then you raise them up on somebody's ballot, then they are still going to be the winner. That is what the monotonicity criterion is all about. If somebody was going to win before, in this case, there's a sort of a specific name for this kind of change. This change in this case is, I'm going to call it boosting the winner. That's because B was the original winner, and when I made that change, I just raised them up even higher. This means they're just going to win like even harder, right? They were the original winner, and we boosted them up. All right. Okay, check it out though. I would like to look at this same example. That was using the borda, right? I want to look at this same example. I hope you don't mind if I just copy it over here. All right, same example here, but I would like to do this using ranked choice. All right, this may be a nice little review. I hope you remember how to do the ranked choice. I will definitely ask you to do this on the test. I'll show you an example like this and say, find me the winner using the ranked choice. If you know how to do it, it's not that hard. What you got to do is you do the rounds, right? In the first round, you count up as if you were doing the plurality, how many top position votes everybody has. In the first round, A has 5, B has 4, C has 4, right? B has 4 because it's these 3 plus another 1 here. And we eliminate the person with the lowest number. Anybody remember there's like a technicality rule? What do you do when you have tied for worst here? Yeah?
They both get eliminated.
Yes, we eliminate both of them. And so these are both eliminated. And actually, we don't have to do another round. That means A is the winner, all right? A wins with the ranked choice, okay? Now, I'm going to try to do... Question? Yeah?
What if all 3 have the same amount?
If all 3 are tied, then they are all eliminated and you say it's a tie or there's no winner or something like that. Yeah. In the real world, this basically never happens because that's statistically very unlikely. But yeah, in a made-up example, that can happen. You eliminate everybody in that case. I think that will never happen in any of the examples that we do in class. All right. I want to do the same kind of a thing where you imagine somebody boosted up the winner. So in this example, I would imagine... Now, I'm not going to do the same thing as before. Remember what I did here? This actually is boosting the B, but not the A. I want to do an example here because in ranked choice, A is the winner, right? It's different from in Borda, B was the winner. But anyway, in this case, I want to imagine that these B, A, C, the last person there, changes to A, B, C. So again, we are raising the winner up on this ballot. All right. How does this affect the election? So now doing the ranked choice again. This time it's a little less clear. Like in Borda, you can just say, well, that means they get more points, so they still win. But in the ranked choice, you know, it's less clear exactly what's going to happen step by step. But let's see if we can work it out. So I'm going to draw this chart again with this change made. So this BAC turned into ABC. So the same chart again, but with that change. 5 people said ABC, 4 said CBA. 3 said, sorry, I'm off the bottom, BCA. And then that last column used to be BAC. I'm changing to ABC. This is a change which helps A, right? It raised A up. A was the original winner, and I raised them up on one of the ballots. Okay, now let's find the ranked choice winner this time. So in round 1, I count up just the top positions. This time A has even more, right? It was originally 5, but now they get this one too, so that's 6 for A. B is 3, C is 4. So B is eliminated, and actually this time we are gonna have another round because only one of them got eliminated, all right? So eliminate B, all right? And then the final round, round 2. Would you mind if I just sort of do a little cross out here? I'm going to cross out B wherever you see it. And then I'm going to count up. Can you even see that? I use my dotted line. And now I'm going to count up the winner between A and C. So how many people put A above C? That would be this 5 people here plus 1 more. These 2 had C above A. So that's 6. And then how many people have C above A? These 4 and these 3 both put C above A. That's 7. And so C is the winner. All right. When we do the ranked choice after making the change, C is the winner. I don't know if you're capable of paying attention so far, but this is actually an insane result. Anybody feel like this is insane?
Yeah.
Yes? Can you say why?
I don't know. It's mostly just instinct because it got last place the most amount of times.
Yeah, it has to do with the fact that we made this change, right? In the original election, A was the winner, And then we made that change, and now C is the winner. Why is that weird?
Well, A was being put in that position with more votes in the first round. It was being raised up. So.
Yeah, right. Think about what the change was. A was the original winner, and then I made a change to make A even higher. And this caused A to lose the election, all right? This is the craziness. This can happen with the ranked choice. Sometimes if you raise somebody's vote up, it actually makes them lose rather than making them win even harder. The question?
We already, like when we changed it, and now we have the updated list.
Yep.
Then the first and the last one is like the same, ABC. What if we just like would put it together as 6?
With a 6?
And that would it be the same result?
Yeah. That's a good thing to notice. This column and this column are the same now. So if you like, you could combine them and make it a 6. It's the same. All the numbers will work out the same way. Yeah. All right. So the moral of the story here is sometimes in ranked choice voting, boosting up the winner will cause them to lose. This is messed up. And this actually, in my opinion, is a good mathematical objection to the ranked choice system. You know, nowadays in American politics, the ranked choice is a bit of a hot button issue. Some people think we should change to ranked choice. Basically, the Republicans hate ranked choice. They think it's well, I don't know what exactly they think about it. Usually they say it's some kind of scam, which it's not. But it is a fact that ranked choice now, at this time in American politics, would benefit the Democrats if we switched to ranked choice, and it would hurt the Republicans. And this, it doesn't matter what your reasons are beyond that. This is enough reasons for all of the Democrats to support it and all the Republicans to be against it. But anyway, this is a mathematical reason to not like the ranked choice, because this kind of absurd thing can happen. Sometimes boosting up the winner will cause them to lose. If you think about the real world, what this means is, like in the real world, when you're doing real elections, obviously during a campaign, it is a candidate's goal to convince you to vote for them, right? What this means is actually in the ranked choice system, there are some scenarios in which it's actually beneficial to me if you vote for somebody else. Like there are some scenarios in which it actually helps me for somebody to vote against me. This is a very weird situation. All right, this is what the monotonicity criterion is all about. So let me just say what the monotonicity criterion is in sort of somewhat technical language. This is the monotonicity criterion. So here's the definition. We say that a system satisfies monotonicity when if some voters change their mind to boost the winner. What happens if you boost up the winner? They should still be the winner. That's the idea. If you raise the winner up on the ballots, they should still be the winner. So if some voters change their mind to boost the winner, then the winner shouldn't change. That's another way of saying the winner should still be the winner, right? It's not like you raise the winner up a little bit and that causes somebody else to win. That doesn't make any sense. So this is called the monotonicity. This is the meaning of, like I said, monotonicity. Monotone means sort of same direction. If you raise up the winner, this should make them still be the winner. It should not cause them to go down in the results. All right? This is the monotonicity criterion. And what we have seen so far is that the ranked choice voting does not satisfy monotonicity. It's because that example that we just did showed that sometimes you can raise somebody up and that actually makes them lose in the ranked choice. All right? So I'm going to go back to my chart at the top there and put a big old X under ranked choice. X does not satisfy monotonicity. You know, I said a few times ago that actually I do kind of like the ranked choice in the real world, but I don't think it's perfect. And one major thing that I think is a problem with the ranked choice is that it doesn't satisfy the monotonicity criterion. This means it does weird things mathematically sometimes in some situations. Now it is a fact that these situations are kind of rare. Like in the real world, you ordinarily would not expect this to happen, but it is theoretically possible. All right. So the ranked choice does not satisfy monotonicity. Can we talk about the other ones? The other ones on the list there. Yeah. Yeah, I think we already explained that the Borda does satisfy the monotonicity because, well, can I write down the explanation? Borda does satisfy monotonicity. Maybe we could, let's imagine this was like a test question. Borda does satisfy monotonicity. How do you demonstrate that something does satisfy? You have to imagine that one of these changes is being made. So I'm going to write, you know, this is very similar to the criteria things that we were writing last time. Yeah.
How do we know that Borda satisfies off of just one example? If there's a different example and it doesn't satisfy?
Yeah, right. This is a good point. What we did was we talked about one example. Really, we need to explain this in all possible cases. Imagine any scenario. So this is how I'm going to write it. I'm going to say imagine X is the winner. And then we change some ballots. To boost X, all right? And then you need to, so that's the setup of the monotonicity. You don't have to think about this part yet. That first sentence, that's sort of what you remember. That's what the monotonicity is about. Now your job is to kind of fill in the blanks and eventually finishing off by saying, you know, thus X still wins. All right? So what do we need to explain in the middle? You have to explain to me why X will still be the winner if we're using the Borda, I should say. We're talking specifically about Borda. So I'm going to say then X still wins using Borda. Anybody want to think you can explain? How do you know if they were going to be the winner and then you move them up on some of the ballots? How do you know they're still going to be the winner if you use Borda? Yeah.
So all that happens is they get more points.
Yeah, that's right. You better say something about points because that's what the Borda is about. All that happens is this X is going to get more points and somebody else is going to get less points, but nobody else is going to get more points, right? So X, why is X still going to be the winner? That's because then X will get more points and everybody else either loses points. If you know, to move X up, you have to move somebody else down. So somebody else is going to lose points. I will say everybody else either loses points or stays the same. And that is why X will still be the winner using the Borda. All right? So this is the structure of what you have to say in order to demonstrate that something satisfies the monotonicity. You imagine that somebody was going to win, and then you boost them up, and then you somehow explain why they still have to win. In the case of Borda, it's because of the points. And if this was, you know, this would be a typical test question about the monotonicity criterion. I would expect you in the middle here to say something about the points. If you're not talking about the points, then you're probably not talking about the Borda, right? All right. So the Borda on the chart, I'm going to put an X. The Borda does not satisfy the monotonicity.
Yes, it does.
It does, yeah. Sorry, I'm not going to put the. I'm going to put the check, not the X. Yes. Sometimes people ask me, should I memorize this chart for the test? My answer is not really. I would say, like if you ask me, I don't have this chart memorized, but I could within 30 seconds or so, thinking about any one of these things, decide for myself which way it goes. So you shouldn't have the chart memorized. That probably won't help you out. But you should be able to reconstruct this chart on your own if you had to. All right. What about plurality and the Condorcet? Maybe I'll give you a moment to think about the plurality. So I'll tell you, the plurality does satisfy the monotonicity. This is one sense in which the plurality is better than the ranked choice, mathematically speaking. The plurality is absolutely better than the ranked choice as far as the monotonicity property goes. So I would like for you to try and tell me. I'll give you a few moments to think about it. You want to write something like this. It should have the same structure except for the middle. The middle part will be different, right? But otherwise everything will be the same. I want you to explain why plurality satisfies the monotonicity. Explain why plurality satisfies monotonicity. All right? It should have exactly the same structure. And in fact, you can write just the exact same first sentence. The second sentence will be different because plurality is not about points. And then the last sentence will be the same again. I'll give you a few moments to think about it, and then we'll discuss. I give you one more minute to write your one sentence in the middle.
Well, it's this.
You gotta wait one more minute. All right, your 1 minute is up. Anybody think you can fill in the blank in the middle? I'm hoping for somebody else. Anybody write anything in the middle? Mm-hmm. Yeah, you got something? You're waving your hand around. I wasn't sure what it meant. I'm going for it.
I said, so imagine X is the winner. X gets a boost in votes by changing out the ballots. Then X will simply get more points while everyone else remains the same.
Mm-hmm. Can you say it without using the word points? This is about plurality. Votes? Be a little more specific than that, perhaps?
First place votes.
Yeah, that's what I want to hear. They get ranked in the first position more times, maybe, right? I mean, they, if you raise them up on somebody's ballot, if you boost them all the way to the top, they're going to get even more votes in the first position. Yes, I would say the word points is not good to use in this example just because it sounds like you're talking about Borda if you use the word points. And it's a little ambiguous if you just say they get more votes. I mean, everybody gets votes in this kind of system. It's just a matter of they are getting more rankings in the top position. So we changed ballots to boost X. Then, so my sense I would fill it in the middle. There are many ways you could say this, but it should be something like then X gets more rankings in the top position and all others stay the same or decrease, right? It's actually not enough to just say X gets even more because, I mean, in theory, somebody else could also get even more, but that's not going to happen. When you boost X up in the plurality system, it means X gets more and nobody else gets more. All right, so then X gets more rankings in the top position and all others stay the same or decrease. And that means that X still wins using the plurality. I hope you wrote and thought something like that. Any questions about that? This is a typical question that I could ask about the monotonicity. So there should be a check in that position. Did I put it there? Yes. What about the Condorcet? Actually, this is the one that I was going to put on the homework, and I accidentally put it on tomorrow's homework. I meant for it to be next week's homework. Anyway, this is, can I just tell you, this is a check, although I'll leave it to you to write down the details of that for the homework. All right? Great. So that's all I wanted to say for now, at least, about the monotonicity criterion. It's pretty straightforward, I guess. It's a little complicated, but and when you tell your friends, oh yeah, this is the bad thing about the ranked choice system. It's a little complicated to explain, but I think it really makes a lot of sense once you think about it. All right. Like I said, my goal for today is to talk about one more column here and also one more row, one more voting system. Can we talk about another row here? I'm going to add on a new voting system. Can you believe it? This is kind of a, would you mind if I say, a stupid voting system. There's something stupid about this, although mathematically speaking, this is something you already know about mathematics. We actually like to talk about stupid examples a lot. I'm referring to something like the number 0, which from a certain point of view doesn't really mean anything, and it's not. It means nothing, and so like, why do you even count that as a number? Because it's nothing. The answer is like, okay, yes, it is kind of stupid, but actually, mathematically speaking, it's super useful to consider 0 as a number. So the fact is, mathematicians really like actually talking about stupid things just as a comparison with other things which are less stupid. So here's a stupid voting system in which this is a voting system which is sort of by design meant to be sort of a bad system which does not obey the various properties that we would like of a voting system. This is a real world system. Dictatorship. What the dictatorship system means is, before you do the election, one voter is chosen to be the dictator. In the real world, the dictator is chosen by, like, who has the most guns or something like that, or whose daddy was the dictator. This is how real world dictators are chosen. But anyway, the way the dictatorship system works is, before the election, one voter is chosen to be the dictator. Then everybody votes, but nobody's vote matters except for the dictator's vote, and that's the one that determines the winner. So one voter is chosen to be the dictator, then everybody votes, but only the dictator's vote decides the election. And typically the dictator votes for themselves and they win the election. All right? This is called the dictatorship system. Now, in the real world, we don't usually think of dictatorship as a voting system. In a real dictatorship, there's no point in voting at all, because the dictator just does whatever they want. You don't have to have a vote. But actually, in the real world, in real dictatorships, they often do have sort of like sham elections. You know, in North Korea, they have elections where everybody goes and votes for the new Kim guy, whoever is the dictator. They still have the election, though. Often, like, the ballots will only have one name on it, and everybody just checks the box while a big guy with a gun stands and looks over your shoulder. This is how dictatorship works in the real world. We are going to imagine this as a voting system, though, where everybody is voting, but then when they count the votes, they just throw away everybody's vote except for the dictator's vote. That's the only one that matters. All right? You should think of this. I am talking about this in a technical way, not to suggest that this is how we should really do things in the real world, but as an example of a sort of degenerate voting system or a stupid voting system, which is useful in order to compare it to other voting systems. All right, this is the dictatorship system. I would like to know which of the criteria does the dictatorship satisfy. So I'm gonna, up on my chart way up here, I'm gonna put the dictatorship as, come on now. Actually, this is gonna be the last row on the chart. The dictatorship. Which of these properties does it satisfy? You got an idea about the majority?
Unanimity, it would satisfy?
It does satisfy. Can we just go left to right? I think that's correct, actually. But what about the majority? I hope you remember the majority criterion means if a majority of the voters vote for somebody on the top position, then they should win. Is that true in a dictatorship? The answer is no, because the dictator could vote in a way which is different from the majority's opinion. So there's going to be an X right there. I'm going to try and write some words to that effect. Sorry to keep scrolling. So let's just think about dictatorship. Dict does not satisfy the majority. This is because even if a majority, that is more than 50% of voters, rank someone in the top, that person may lose. This is the whole point of a dictatorship. If you ask me, what's good about a dictatorship? You don't have to let those pesky majority candidates win the election. Somebody else can win, all right? This is good if you're the dictator. It's bad if you're an ordinary person. Okay, so the dictatorship does not satisfy the majority criterion. What about the unanimity criterion? Remember, this one says if all voters rank X above Y, then Y should not be the winner. That's what the unanimity says. If all voters rank X above Y, then Y should not be the winner. And you have to keep in mind, in our concept of dictatorship here, the dictator is one of the voters, right? They count as one of the voters. So is the unanimity property satisfied? I think somebody said yes, it is. And actually, yeah, the answer is the unanimity property is satisfied by dictatorship. Can we say why? Maybe as a little review. Remember, the way to explain why the unanimity is satisfied, you have to say, imagine all voters rank X above Y. This is how you describe that something satisfies the unanimity. Then you say something in the middle, and then you conclude, then Y does not win. Can you explain why is it in a dictatorship if all voters rank X above Y, how do you know Y is not going to win? Yeah?
Because that includes the dictator.
Yeah, because the dictator counts as one of the voters, and so if the dictator puts X above Y, then definitely Y will not be the winner, right? So imagine all voters rank X above Y. I'm just going to try and write some sentence that describes what I just said out loud. Then the dictator prefers X above Y because the dictator is one of the voters. And that's it, right? the dictator prefers X above Y, and that means Y is not going to win. All right? It means maybe X is going to win, but actually maybe the dictator likes somebody else even better, and so X might not be the winner, but definitely Y is not the winner. All right? This is the unanimity property. So the unanimity is satisfied by the dictatorship. Hey, it's not looking so bad, right? One X, one check. Come on now. How about the Condorcet winner criterion? This one means, remember, if there was a candidate who would win in every pairwise matchup, are they automatically going to be the winner in a dictatorship? I would say no, because the dictator can just choose somebody else if they want to, right? The fact that one candidate wins every pairwise comparison does not mean that they are the one the dictator is going to choose. And so the Condorcet winner gets a X. The dictator might choose somebody different from the one who wins all of the pairwise matchups. All right? And how about the monotonicity? This is something that deserves talking about in detail, perhaps. The monotonicity. Come on. I'm trying to scroll here. How about monotonicity?
No.
Remember, this is the one where if somebody was the winner, and then you change some ballots to raise them up, are they still going to be the winner? That's what the monotonicity says. So I'm going to say something like, if X is the winner, then we, well, I like to start with the word imagine. Imagine if X is the winner, and then we change ballots to boost X. All right? Is X still going to be the winner in a dictatorship? Yes, I see some yeses. Can you say why? Maybe I saw you.
Because the dictator will still vote for it.
Yeah, if you imagine that X is the winner, what that means already is that the dictator thinks X is the best, because that's the way that X became the winner to begin with. And then if you change somebody's ballots to raise the X up, it doesn't matter, right? Because the dictator is still going to think X is the best. If you change the dictator's ballot even to raise X up, X is already at the top, so that is not a real change. Okay, so if X is the winner, then we change ballots to boost X. I will say since X won originally, they are the dictator's favorite. So they still win. Right? Even after you boost them up on some of the ballots, it doesn't matter. They were already the dictator's favorite, and so they are still going to be the dictator's favorite after you make the change, and so they still win. All right? So the dictatorship satisfies the monotonicity. One thing that you can say, so one thing that I want to bring to your attention is like this chart is meant to judge whether certain systems are better than one another. Although it's not really, you can't just say like, oh, you get, for example, the Borda has 2 checks here, and the dictatorship also has 2 checks. So I guess Borda and dictatorship are like equally valid as democratic systems. The answer is that's not true at all. The dictatorship is not valid at all as a democratic system. So you can't just sort of go by counting up the check marks on this chart. But these are very specific mathematical ways to compare. Like you can say, mathematically speaking, the ranked choice has an X here, but the dictatorship has a check. Does that mean dictatorship is better than using ranked choice in the real world? I would say, well, as far as the monotonicity criterion goes, yes, the dictatorship is better than the ranked choice. But that doesn't actually mean that you should do it in the real world. These are mathematical facts here. What specifically this means about how you do this in the real world is up to your interpretation of how much you care about these mathematical facts. All right? Great. Okay, I have one more column. We got about 20 minutes remaining, and I think that maybe I'll just give you a little intro to the last column here. This has a fancy name, which is going to be abbreviated IIA. And this is actually the last column that we're going to put on the chart here. So it fits quite nicely here. All right. This is called the IIA. So this is also a criterion. The IIA is also about changing people's votes, but it's in a different way. Monotonicity is about boosting the winner up higher, all right? IIA is not about that. It's about changing things in a different way. So the very, very basic idea of IIA, this is, it stands for independence from irrelevant alternatives. That's what IIA stands for. But I'm always going to write IIA. The idea behind this, the very simplified idea behind this, is that if we make irrelevant changes to the ballots, this should not change the result. All right. So this is also about what happens when people change their minds, but this one is about changing around irrelevant things. The monotonicity is about changing the position of the winner. The IIA is kind of about shuffling around the losers. So that's what is, in a vague sense, meant by irrelevant. It's sort of like shuffling around the losers. And the idea is, if all you do is move the losers around, then it doesn't matter. The results of the election will be the same. All right? It's a bit like if in the Bush-Gore-Nader election, if I voted Bush-Gore-Nader and Gore was the winner, and then I said, no, wait, I changed my mind. I meant to say Bush-Nader-Gore. The response is like, okay, fine, but Bush is still the winner because all you did when you changed your mind was change around the losers. That shouldn't matter, all right? That's what the IIA criterion is about. If you change around the positioning of the losers, then it doesn't matter. Let me just say specifically, this was the vague idea. I'm going to give you the real definition here. We'll talk about one example, and then that'll do it, because I wanted some time to talk about the test. So let me just give the definition and then example. We'll talk about this more next time. So it says, this is the IIA criterion. So a voting system satisfies IIA when if there is a winner the first time around, if there's a winner, and then we change some ballots without moving anyone past the winner. So on somebody's ballot, if the winner used to be on top, they're still on top. Or if the winner used to be on the bottom, they're still on the bottom. You don't move anybody past the winner. That is referred to as an irrelevant change. And so if there's a winner and then we change ballots without moving anyone past the winner, then the winner stays the same. The results don't change if you make that kind of change on the ballots. All right? So here's a very specific example. This is the IIA criterion. It says you change your mind, but you don't move anybody past the winner when you change your mind. Here is a single example. This will do us for today. Let's say 3 people said ABC, 2 people said BCA, and let's do this using Borda. All right. Let's calculate the answer first. So this is the original election. I'm going to make a change, but we should figure out who the winner is to begin with. So the winner in the beginning is my points. Remember, for the Borda, my points go 0, 1, 2. So the points for A is 3 times 2 plus 2 times 0. That's 6. The points for B is 3 times 1 plus 2 times 2. That's 3 plus 4 is 7. And the points for C is 3 times 0 plus 2 times 1, that's 2. All right, so B wins in the original election, all right? Maybe just to help myself keep track of that, I'm going to circle the B's, okay? And now I'm going to try to make a change, sort of a so-called irrelevant change. What if this time I am going to change the BCAs to BAC, all right? I'm going to change the BCAs to a BAC. And I will just point out, this change did not move anybody past the winner. All I did was exchange the losers without moving anyone past the winner. So this doesn't move anyone past the winner. All right, what are the results then after the change? I will redraw the chart here. It says 3 people ABC, 2 people BAC, and now I'm going to do the Borda again. 0, 1, 2. So this time A has 3 times 2 plus 2 times 1. That's 6, and 2 is 8. Is that right? Yeah, okay, sorry. I don't know why I just confused myself. B gets 3 times 1 plus 2 times 2. That's 7. And C now gets straight up 0. All right? And the winner this time is A. So, having made that change, B used to be the winner. We changed votes by not moving anyone past the winner, and that actually changed the winner. This is a change which was supposed to be irrelevant, but it ended up actually affecting the results. All right? This here is a demonstration that Borda does not satisfy the IIA. That's because in the Borda, you can actually change the results by shuffling around the losers. All right? This is a strange fact about Borda. So Borda does not satisfy IIA. You can change the losers around. I will say in a very informal way. What that means is that swapping the losers can change the winner. That's what just happened in that election. And this is regarded as generally undesirable. That you can swing the results of who wins by just changing around who's losing, by just interchanging the losers. All right. So can I put a little something on here? IIA Borda is a X. All right. We're going to fill in the rest of this next time, but we got 15 minutes remaining. Any brief questions about this IIA? We'll talk more about this next time, so you don't have to be an expert about that. Can we just talk briefly about the test, if you don't mind? So I have here my my little checklist. I hope that everybody still has one of these. I suppose you don't need it, but after the first test, you definitely will want to have this. It's at the class website. You can print out another one. I'll bring some more some other time. Remember the way, I hope that everybody's clear on the way the grading works. On the test, you will see a question for each of these items that we've covered so far. And if you answer the question correctly, then you never have to answer that kind of question on any future test. If you get it wrong, that's okay. There's no penalty. You better get it right at some point before the end of the semester. Every test for the rest of the semester will have a question about monotonicity on it. It's best for you if you get it right the first time, but if not, you can try again next time. So I'm going to write down, I see a question, I'm just going to write down the topics that will be on there. So the test on Friday covers, on my list here, it's A1 through A8. That's 8 questions. I said 9 before because I wasn't sure how far we were going to get. The 9th one will be IIA. Let's just postpone that to next time. So A1 through A8 on the list, that is I will tell you in case you don't have this memorized. So A1 is the plurality system. You should expect this question to be really easy. I show you an election and I say, who's the winner using the plurality system? I hope that you know how to do that. Or I might ask you some other question about the plurality system, although there's not really anything hard that I could ask you about the plurality system. Okay, A2 is the ranked choice, which is also fairly straightforward. I mean, it's a bit more of a procedure to go through doing the ranked choice. A3 is the Condorcet method, which is, in my opinion, still a bit more complicated. This is the one about doing the pairs. A4 is the Borda. Fairly simple, easy to mess up, but I mean, if you just mess up the numbers, then I'll still give you credit, just because I mess the numbers up all the time myself. A5 is the majority criterion. In my opinion, these criterion questions will be a little bit more difficult just because you actually have to think about, so I might ask you something like, explain to me why the ranked choice satisfies the majority criterion. And you have to write one of those sort of little logical arguments in probably 3 sentences, the way that we've done several times before. The A6 was the unanimity. The A7 was the Condorcet winner criterion. And then the A8, that'll be the last thing. That's the monotonicity. Now, I know we just covered this today. Ordinarily, I wouldn't make you do something that we just covered on a test on the next class, but I figured there's no penalty if you get it wrong, so I might as well give you a chance to do it right this week for the monotonicity. Yes?
For the criterion questions,
Yeah.
should we prepare just to fill in that middle part, or are we going to have to know, like, write each?
No, you should know, you should be able to write the whole thing, yeah.
Okay, well, thank
Yeah.
you.
Yes?
Could you maybe also like put the A9 already in for the A?
So the next one would be the IIA, I think.
I mean, there's no penalty if it doesn't.
Yeah, I guess, sure. How about I'll put a, she said, can't you just put the IIA on there? You might get lucky and get it right, and then you want to do it next time. So I'll make an IIA question on there, even though we only talked about it for 10 minutes. I saw another question.
Would you say one question that doesn't fit the criteria or only does?
I could, yeah, she asked, would I ask you to show something does not satisfy one of these criterion? I would say yes. I might ask you, for instance, to explain why the dictatorship does not satisfy the majority. Or this would be a little harder, but show me an example where the Borda does not satisfy the majority. That's the one where somebody in second place can get enough points to win. Those are a little harder. So if I asked you about the does not, it would, you know, I'm not trying to give you really hard ones, so it'll be easier. I might say, I might give you an example already and say, explain to me why this shows that something does not satisfy something. Something like that. Anything else? Everybody was leaving, and then you stopped leaving. I appreciate it. But now I think maybe you should leave again. It seems like nobody has more questions. I'll hang around. If anybody does have more questions, let me know. Don't forget to send in the homework tomorrow. See you Friday.